Hello everyone and welcome back. So in this video I'm going to go over several basic properties in integration that you must know before calculus 2. Okay, so let's get started. First, to integral. What you have to integrate is a function that is multiplied by a constant k. Now according to the rule, what you can do is you can pull out that constant outside the integral and you can just integrate f and then later multiply by k. Now you can do that because you have multiplication between k and f. You multiply f by k. The whole function, you multiplied it by k. Okay, all right, so let's look at an example. Example is the easiest way to understand this better. So you have to integrate 3 times x with respect to x. The function here is x, the constant is 3. Now 3 is multiplied by x, or x is multiplied by 3. That's the better way to put it. So what can we do? Let's pull out that 3 out of the integral. So then we have just x. Now let's just integrate x, only x, okay? So if you integrate x, what do you get? Well, if you integrate it, this is x to the power 1, so you can use rule number 2 in my note packet, okay? So that will be x square 1 plus 1 over divide by 1 plus 1, right? X square over 2 plus 6. So this is what you get if you integrate x. Now you have to multiply everything by 3, right? So what you get is 3x square over 2 plus 3c, right? But here's the thing. C is an arbitrary constant, okay? So since it's arbitrary, you can just say 3 times c is also an arbitrary constant, right? So you can just say it's c. Okay, there's no problem. So really when you do this, you don't have to have this bracket. You can just your final answer like this. All right, okay, let's go to the second rule. Now the second rule says you have to integrate f plus g. Now you have two functions inside the integral, but they are connected with just addition. The operation, the relationship between them is only addition. Do you see multiplication anywhere else? Do you see subtraction anywhere else? No, just addition, right? When you have that, what you can do is you can integrate these two functions separately and later add them up. So let's look at an example. If you want to integrate x plus 2 with respect to x, well, you have x and you have 2. So let's integrate x separately and 2 separately, right? And then add. Okay, so if you integrate x, you get x square over 2 plus if you integrate 2, you get 2x, okay, plus arbitrary constant c. Now if you have forgotten how to integrate a constant or a power rule, click on the link on above the video so that you can watch rule 1 and 2, review rule 1 and 2 really quick. Okay, so this is what we get. Now here's a question. Now you might ask, can I pull out 2 here? That was here, it's a constant. Can I pull out of the integral? No, because here in between x and 2 you have addition, not multiplication. So you cannot use the first property in this example. Okay, see the difference. All right, the third property is that instead of addition, if you have subtraction, you can do the same. You can integrate the two functions separately and you can subtract. Okay, all right, so what we have to do right now is do several examples. Okay, first example we are going to do is we are going to integrate negative 2x plus 3 with respect to x. Okay, now what can we do? Now we have addition here. We can integrate negative 2x separately, 3 separately and add, right? But here's a question. Can someone say, can I pull out 2 out of the integral and write it like this? No, right? It's much more complicated than rule 1 here. You cannot do that because you have addition in between. Don't ever do that mistake, okay? Remember, the first property says if you want to pull out that constant k, it has to be multiplied by the whole function f. But here, it's only multiplied by x, okay? Not 3. So this negative 2 does not belong to 3. So you cannot take it out, okay? You can take it out. If you want to do that, you have to have negative 2 here. But let's not do that, okay? Let's do it in this easy way, where we integrate negative 2x separately and you integrate 3 separately and you add. Now since you have separated, now can you take that negative 2 out? Absolutely yes. Okay, so now you can write this as, you can pull out negative 2, you just integrate x, and here integrate 3 separately. So if you integrate x, you get x square over 2, here plus because of this plus, and if you integrate 3, you get 3x plus arbitrary constants. Okay, so this is what you get. All right, so let's do more examples. Now how about if you have 3 terms? Okay, so you want to integrate 3x square minus 5x plus 2 with respect to x. Now you don't always need to show that separation, show that application of property every time you solve a problem. You can do that until you get comfortable, but after that you can do the integration right away by one line. So how do you do it? Separate every term in your mind. Integrate every term separately in your mind. Okay, that's the better way to put it. So if you integrate 3x square, what you get? 3x cube over 3, right? Minus, if you integrate 5x, you get 5x square over 2. Plus if you integrate 2, you get 2x plus arbitrary constant c. So this is, I use those both first property and second property in a one line inside my mind. Okay, this should have been like, I integrate x square separately, I integrate x separately, well negative 5x, I integrate 2 separately. Okay, all right, so this is what you get. You can simplify 3 and 3, you can write x cube minus 5x square over 2 plus 2x plus c. Okay, so this is the answer you get when you integrate this function. Okay, let's see another example. Well, we have x to the power half plus x to the negative 2 plus 1, and you integrate with respect to x. Okay, now let's integrate separately. So if you integrate x to the half plus 1 over half plus 1, plus if you integrate x to the power negative 2 plus 1 over negative 2 plus 1, if you integrate 1, you get x. 1 times x is x plus arbitrary constant c, right? Now if you half plus 1 is 3 over 2, divide by 3 over 2, here plus negative 2 plus 1 is negative 1, here negative 1 plus x plus c. Let's simplify furthermore. Here x to the power 3 over 2, divide by 3 over 2 means multiplied by 2 over 3. That's reciprocal multiplication. We discussed that in the first video. So if you want to learn that, click on the link above. Here, let's take this minus in front of the whole term here. So minus times positive here is minus. X to the negative 1, let's take it to the denominator. So it's become x to the power 1 plus x plus c. Okay, so this is the answer you get if you integrate this function here. Okay, let's do another example. All right, final example. How about if you have a big one? 6x cubed 9x square plus x minus 2 with respect to x. Now you have several functions. Okay, so still you can integrate separately. You doesn't need to always have 2 functions to apply the property. Okay, you can have as many as long as they are separated from subtraction and integration. So let's do this. So if you integrate 2x to the 4, you get 2x to the 5 over 5 minus 6x, 3 plus 1 is 4 over 4 plus 9 x3 over 3 plus x square over 2, here power 1 minus 2x plus c, right? Simple, right? So let's simplify this. 2x to the 5 over 5. Here we can divide by 2 here 2, we can cancel by 2, so here 3x to the 4 over 2, here 3 and 3 x cubed plus x square over 2 minus 2x plus c. So this is the answer that you get after you integrate this function. Okay, so then that's it. That's how you use those properties to integrate. Okay, And to learn more, watch my next video appear in this in the link that appears in this video, and because of that I will catch you in the next video. So thank you very much for watching this video. Bye bye.